Okay, everyone. So let's start the class. Hello, Sarah Beg. Assalamu alaikum. How are you?
I'm fine, sir. How are you?
I'm good. I'm good. Thanks so much for asking. Everyone, please switch on your videos. Sarah, Farhan, Sarah, and Irshad. Sure, Sheikh. That's great. So in the last class, what we were discussing, the inertia topic, right? It means okay, I think so. We have discussed the first law of inertia, first law of motion.
Yes, sir. Not.
Yes, sir.
Yes, sir. First law.
First law of motion. Na? So, okay. So it means that we have to start. So as I've told you that inertia depends on the body, or sorry, basically on the mass. That higher the greater the mass, greater will be the inertia of that body. Here.
Yes, sir.
Yes, sir. Sure, that's good. Okay. So we need to exert the external force to move the stationary body because to overcome the inertia of that body. Clear, everyone?
Yes, sir.
Yes, sir. Sure, that's great. Okay. So basically, let's take some conceptual question based on that. Okay. So you can see this thing that you must have seen that when you basically beat a carpet or you can say a kind of you can say quilt with the help of a stick, the dust
sir.
particles comes out from it. You must have seen that and they get suspended
Yes,
in
sir.
the air, right? Have you seen
Yes,
that?
sir.
Right. So it means okay. So basically, what happens in that case is the basically dust particle wants to remains at rest, but due to the continuous beating by the stick, the basically that produces a motion. Therefore, the dust particle will move, and that's why you can see the particles in the air. Clear, everyone?
Yes.
Okay,
Yes, sir.
when hanging
Yes, sir.
carpet is beaten with a stick, so dust particle comes out from it. Okay, okay. So that's
Yes.
great. Okay, and basically, when this, as I've told you that for the bus example, when this when a bus or car suddenly starts or stop, there is a kind of you can say jerk. You can say experienced by the passengers, right, in the forward and backward direction, respectively, according to the situation. Clear?
Yes, sir.
Sure, that's great. Okay, so let me write it down. So if we take the example, is beaten, resting, the dust particles coming from it, coming out of it. Due to the change in the inertia. Okay. Force of stick makes the carpet move to and fro, means like this pendulum motion. Okay, slightly. But the dust particle remains at rest, so that's why they come out of the but the dust particle and
What is after particles?
tend T-E-N-D tend
Okay, sir.
at rest due to their inertia. Hello, Ifra, assalamu alaikum. How are you? Ifra, am I audible? Inertia and hence separate from the carpet. So this is the reason. Clear? अच्छा ठीक है Ifra. Ifra, please join the class on regular basis. Do not miss the classes. Okay? If you miss the classes on the frequent basis, you won't be able to cover up the syllabus. Separate from missed the last class, right? Yesterday was a class. I think so. Yesterday we had a class then.
Yes, sir. Yesterday at
So
9:30.
yeah. And if you miss these classes, you won't be able to cover up your syllabus. Please do not miss. I'm saying to everyone, please do not miss the classes because right now this chapter would be done in this month itself because right you will be having exams in the September month. So this chapter would be done so that you can at least prepare and revise. Okay. So this is the example. Okay. So when the running car or bus stops suddenly, the passengers are jerked forward due to the passengers of the inertia tend to remain in the motion, and the bus stops. So that's why they move forward. Okay, to maintain their inertia. Okay, to maintain their state of motion. Clear, everyone?
Yes, sir.
Okay. Yes, sir. So that is the reason seat belts are provided. That is the reason seat belts are provided in the car so that if you basically go in the forward direction, so that would help you to avoid any accident or you can say head collision with the dashboard. Clear, everyone? Okay. When a
Yes.
running car, so these are the conceptual questions. So like why do we experience the forward, you can say, push when the bus stops, or why do we feel in the backward push when the bus starts or the car starts, why there is a seat belt in the car. So these are the you can say situation based on the inertia, right, everyone?
Yes, sir.
Yes, sir. Okay, so let's complete this and we'll start the momentum in this class itself.
So this is the last part.
No, one more part is there.
Okay, sir.
Sudden passengers are jerked forward because inertia of motion even though the car or bus has come to rest. Everyone?
Yes, sir.
Okay.
Yes, sir.
And same reason would be for the like a little bit change will be there for the when the car was in when the car or bus is in stop with the rest state. So they will feel the body of the body wants to maintain the inertia, or you can say state of rest. So that's why there is a backward push, right, everyone?
Yes, sir.
Yes, sir.
Okay. EF G part. G part is basically when a car or bus starts suddenly. For passengers, backward. This is inertia. The passenger tend to remain at rest. Okay. Remain. Clear, everyone?
Yes, sir. Clear.
Yes, sir.
Even the bus or car. Let's start. Clear, everyone? Okay. The last part is basically when you try to, like, you can say, you can say, try to deboard from a running bus, you cannot easily, you can say, deboard from the running bus, because the bus is moving, and you want to basically change the state of motion into the rest state. So that would basically fall you in basically with your in front, it's on the road, and there will be a damage to your body as well. Okay, so let me write this thing as well. It is dangerous moving bus because the jumping man. Hello, Rumaisa. Assalamu alaikum. Are you there, Rumaisa?
Yes, sir. Walaikum assalam.
How are you?
Alhamdulillah, sir.
Why did you join so late, Rumaisa?
Yes,
It's
sir.
almost been.
Network issues, sir.
What issues, Rumaisa?
Sir, the network went off. That's why.
Acha, network.
Yeah.
Okay. So after this class, the missing part, you can watch the recording. Okay.
Okay, sir.
With the high speed of the bus. Okay. And would tend to be in, okay, would tend to remain in motion. So that's what remain in motion. Yeah. Even on falling the ground. So please do not do this in the real life, because that is very dangerous. Okay. If you try to jump out from a moving bus or a moving car or something like that, so it's going to be very, very dangerous. Okay. Even in just in the prank as well. Okay.
Yes, sir.
Outside.
Yeah. Yes, Tejas, you are saying something
I think so.
and get hurt. Due to the resistance offered by. Please write this thing, everyone. Check it. Just give me a moment. Please write it and let me know.
Done, sir.
Oh, okay. So is this clear to all of you?
Yes, sir.
Okay. So in the first law of motion, only conceptual questions are there, like why do we like? Why is it dangerous to jump out from a moving bus? Why there is a fall? You can say backward push when the car suddenly starts, or why there is a forward push when the car suddenly stops, and what would happen if you beat a carpet, hanging carpet, or a quilt, or something like that with the help of a stick? So these are the things that will be there. No kind of numerical, only conceptual, purely conceptual based question, or maximum they can ask you that state the first law of motion in the exams. Okay. And what is the factors that affect the inertia? So mass is going to affect the inertia, because higher the mass, higher will be the inertia, right, everyone?
Yes, sir.
Okay. Like students are joining even like half an hour, like in the class, half an hour late. Chalo, okay. Sorry, everyone, for the interruption. Ayan, are you there in the class? Shalom. Maybe he has some internet issue. So momentum. Okay. So next thing that we are going to discuss is momentum. The second law of motion is basically associated with the momentum, because momentum. So let's take an example. For understanding the real, before understanding the actual definition, let's understand this thing. Suppose that a ball is a cricket ball. Everybody has seen cricket ball.
Yes.
Okay. So it's, you can say leather cricket ball, okay, or you can say tennis cricket ball. So when you basically throw a baller, when the baller throws a cricket ball, the ball goes with a very high speed, and if the batsman miss the hit, the ball will hit the body part, right? And it's
Yes,
going to hurt a lot. Yes or no?
Yes, sir.
Because,
yes,
right.
Yes,
So
sir.
it looks like a very small ball, but if you basically throw with a very high velocity or speed, it's going to hurt a lot, right?
yes,
So momentum is the quantity that tells you how much impact or how much effect it will make on the body after the collision. So momentum will tell you that. Impulse and momentum are basically a little bit related thing, you can say. Just a moment.
Yes, sir.
Okay. So right now, impulse is not the quantity in your syllabus. Just okay. So basically, momentum will tell you how fast, you can say, the body is moving. Okay. And momentum is the you can say momentum in definition, you will just say that momentum is the product of mass and velocity,
yes.
right?
So can I tell
Okay.
the
Yes,
formula of
Tejas.
momentum?
Can you?
Nothing, sir.
You are saying something? Yes, yes. Go ahead. What are you saying,
Sir, no, sir.
Tejas? Acha, okay. Okay.
Sir,
So that is
momentum
the moment.
formula is there, right?
हाँ, momentum के numericals भी formula भी है. No need to worry.
Okay.
We will cover everything, Tejas.
Okay.
Okay. So don't worry at all. We are going to cover everything from scratch, and we will do everything in detail. You must have seen that I've taken every conceptual question that is present in the,
Yes, sir.
you can say, in the inertia, right? So we are
Yes,
not
sir.
going to miss anything, right? We are going to do everything in detail. Chalo, ठीक है? Chalo, that's great. Okay, so this is the, okay, now let's understand the momentum definition in terms of the, you can say, book definition, you can say. And you can also say that, तो चलो अभी simple definition ही कर लेते हैं. The momentum of a body. So we must, we like, this is the momentum word we commonly use that we were studying and there was a momentum, right? कहते हैं ना momentum gain, momentum बन रहा था, something like that. हम लोग तो बेसिकली मोमेंटम उसी चीज के रेफरेंस लेके हम बोलते हैं, बिकॉज मोमेंटम इज अ काइंड ऑफ मोमेंटम इज एसोसिएटेड विद अ मूविंग बॉडी, राइट? सो हम लोग जब स्टडी कर रहे होते हैं तो वी यूज लाइक द वर्ड लाइक मोमेंटम, लाइक हम लोग मोमेंटम से पढ़ रहे थे, मतलब देयर वाज अ कांस्टेंट थिंग लाइक गोइंग, योर स्टडीज वाज गोइंग विद सम मोशन, राइट? सो दैट्स व्हाई द मोमेंटम वर्ड इज यूज्ड इन दैट रेफरेंस, ठीक है? सो मोमेंटम ऑफ अ बॉडी इज डिफाइंड, ठीक है, as mass and velocity. Okay, so we denote momentum with P and mass
P is equal to mass and velocity.
into velocity. ठीक है?
Velocity.
This is momentum. Is this clear to all of you? Please do let me know.
Yes, sir.
Yes, sir.
ठीक है? So momentum is basically, the momentum is a quantity which depends on mass and velocity of the body. You can easily see this thing from the formula itself. That this quantity depends only on the mass and the velocity. Clear, everyone?
Clear. Yes,
Yes,
sir.
sir.
ठीक है? Yeah. चलो, that's great. Okay, so this is the quantity that depends on mass and velocity of the bodies. Okay, so Ajabat should tell me, if the body is at rest, what will be the momentum of the body? If the body is at rest,
0.
0.
okay, zero. Obviously zero, because the
Mhm.
velocity will be zero, so momentum will be zero, right?
Yes, sir.
Yes,
Chalo, that's great. Okay, so let's write A part for the, okay. And the next thing is that momentum is a vector quantity, right? So momentum can be positive, zero, as well as negative, right?
Yes.
So momentum is
Or
a
negative. Yes.
vector quantity, ठीक है? And the, you can say the SI unit of momentum is nothing but the SI. देखो, what is the SI unit of mass? That is kg. SI unit of
Yes, sir.
velocity is meter
Meter
per second.
kg meter
ठीक
per
है?
second.
Meter per second.
Yes, kg meter per second. So this is the SI unit of momentum is kg meter per second. ठीक है? So kg meter per second is the SI unit of momentum. And every moving body possesses momentum because every moving body has velocity, right? So that's why it will gain some momentum as well. Is this clear to all of you?
Yes, sir.
Yes, sir.
So what's kg?
ठीक है?
Kilograms.
Yes, kilograms meter per second.
Okay. Okay. Okay, sir.
ठीक है? Sure, that's great. ठीक है? So now let's discuss this thing. Acha, let's modify a little. Acha, before that, let me write down the definition here. Sorry, definition, a word. The quantity of motion in a body depends on a mass and
Velocity of body.
So, okay, okay. So you can see this thing from the formula that momentum is depending on the mass and velocity. It means that if you basically increase the mass of the body, the momentum will also get increased. Clear?
Yes, sir.
Okay? Yeah. So okay, next thing is that you must have seen, like as I give you the example of cricket ball. So cricket ball is not very heavy, but it's very, as you can say, is a small thing, right? But if when it is thrown with a high speed, it will hurt a lot, right? Okay, a
Yes.
car maybe is running. Okay, so when we heard this thing that that there is an accident on the road, car was going with a very high speed and suddenly crashes into the divider or in the car itself. You must have seen that the high impact is produced in that clash, right? In that crash. So that's why, and there's very less, and like that's why these road accidents are worse. Okay, because the cars or the buses are traveling at very high speed, right, everyone? So that will impact a lot in the crash. Okay.
Yes.
Okay. So I'm writing it here. A cricket ball is not very heavy, but when it is thrown, at a very high speed, with a very high speed, you can say, it acquires a large momentum and sometimes hurts the batsman. Okay. So that's why cricket or anything that is basically associated with very high speed, like a like the object thrown at high speed, are playing basically played very cautiously with the proper equipments and the safety guards. Okay, hurts the batsman sometimes. So, and you can see this thing, everyone, that sometimes a car or you can say a bus is basically going with a very low speed, right? So, but when it will hit a body, that will produce a large momentum because of the high mass, right?
Yes, sir.
Okay, and
Yes.
it will also hurt coming in its way. Even it could be deathly as well. Okay,
Yes.
and like high speed road accidents are, you can see, you already know this thing that they are good, like they are very very bad. Okay, so car or bus may not be running at high speed because it is running at low speed, but the momentum is directly proportional to the mass. It means that higher the mass, higher will be the momentum. Clear, everyone?
Yes, sir.
Yes, sir.
sir.
high momentum which may hurt the person. Okay, everyone, clear?
Yes, sir.
Sure.
Yes, sir.
Okay. So, okay, so momentum. So as we, from this, you can conclude that momentum is considered as the measure of quantity of motion of a moving body. It means that how much quantity of motion is there present in a moving body. Clear?
Yes,
Okay.
sir. Clear.
So last point is, after that, we will do the numericals. Momentum is considered as a, is considered to be a measure of the body. Clear?
Yes,
So
sir.
how much motion is present inside a moving body? So that basically gives you the idea. Okay. Now let's
Yes,
do the numerical based on the momentum. So numericals are very straightforward, not that much you can say tough. Okay. So just a moment. Is this clear to all of you that we have done
Yes, sir.
so
yes, sir.
far?
Very clear.
Tejas,
Yes, sir.
Irshad,
Yes, sir.
Yes.
Astitva,
Yes,
Ifra,
sir.
Rumaisa,
Yes,
Yes,
sir.
sir.
Sara,
Clear,
Beg,
sir.
and Sara Khan, Farhan. Chalo, cheek. Okay. Now let's do this basic question. Sufia. Okay, now let's do this basic question. So as you can see, what is the momentum of a man of mass 75 kg, where the velocity of the man is 2 meter per second, and it's a uniform velocity. Okay, okay, that's good. Yeah. So M is given to you as 75 kg. Velocity is given to you as 2 meter per second. Yes, that's okay. Good, everyone. P is M into V. Just substitute the values. 75 into 2 kg meter per second. That is 150 kg meter per second. Okay, everyone. So always remember that unit should be there. Okay,
Sir,
while giving the answer. Yes, Tejas, follow.
sir, I thought we should solve it.
We should.
Solve it.
कोई
Weekly
बात नहीं,
solve
like
it.
no issues, because देखो like this is the first question, so I should like tell you how to implement all the things. Okay, so I'm giving you one more question. No need to worry, because this is a very simple question. I'm giving you one more question. Please try to calculate this one.
Sir,
So in the next class, we are going to discuss the second law of motion, and that is a very important law. All the numericals are based on that law itself. Okay, so we will discuss it, and that is related to momentum. So the momentum is directly proportional. The rate of change of momentum is directly proportional to the force applied on it. So that is the second law of motion. So we will discuss it, and there is a small derivation, or you can say 2 or 3 step calculation to derive F is equals to ma. That should be you can say a 3-marker question at least in your exams. that state Newton's laws of motion, explain it with the help of the proper relation between force, mass, and acceleration. So this could be a अच्छा I got one. ठीक है स्थित ठीक है. Okay, from because it's a very simple question. In this, like a purely momentum concept, very simple numericals are there. Only just you have to substitute P equals to mv and something like that. Okay. But when we will do the conservation of momentum and the forces and laws of motion, and everyone in the next class, please and please revise the equations of motion from the motion chapter. Okay.
Okay,
Do
sir.
solve the numericals and then come to the class. It's a request to all of you. Ifra, Irshad, Tejas, Rumaisa, Farhan, Sara, and Sara.
Yes, sir.
Yes, sir.
Chalo, that's great. Because if you do not revise now, so that will be a little bit tricky for you to understand. So that's why I'm saying please and please revise it. Okay? And this should be a habit of yours that without my you can say revise, asking you to revise, you should revise it before coming to the class. Okay? So
Yes, sir.
mass of the body is given to you as 25 kg.
Yes, sir.
P is given to you as 125 kg meter per second. Okay. So as you know, the always one more thing, whenever you write the exam, form, or you can say solve the numericals in the exam, always write the formula first, which formula you are using, because that will show the confidence of yours in the exam. Because teacher will say, okay, student know this thing, yes. Okay. Okay, Irshad. Good. Okay. Okay. So as you know, this thing that we need the value of V. So V can be calculated by dividing the momentum by mass. So that is 125 divided by 25. So this will be in meter per second. This will cancel this 5 times. So 5 meter per second is the value associated with
Yes,
the
sir.
body. So this is the answer. Is this clear to all of you, everyone?
Yes, sir.
Yes, sir. I
Yes,
got the
sir.
same
Any
answer,
doubt?
sir.
Okay, that's good, everyone. Those who got the right answer. What about Sara, Farhan, and Sara? There is no answer from Sara Beg, Sara Khan, and Farhan. If you do not answer, Bacho, how would you understand, like how you would get to know that you are doing the right thing or not? And even after asking to switch on your videos, Farhan didn't switch on the video. Sara didn't switch on the video. Sara Beg also. I don't know. Like this is not the decorum of this class, Bacho. You have to switch on your video so that we can have facial interaction. If you have any issue, please say it to me. I will understand. Like I will go through it and let you know that whether it's solvable or not. But at least you should inform me, na? If you are having any issue with the, you can say, with the camera or with the mic. Because everyone is giving you, all of you are giving your extra time here, extra resources here. So you should at least be attentive in the class, right? So just a moment, everyone. तो ये क्वेश्चन करो आप लोग. Please do this question, everyone, and let me know the answer.
Okay, sir.
Okay. So Tejas, please like take out your doubt, whatever it is. We will discuss in the class itself. Because
Okay,
after
sir.
that, I will be having one more class. So
Okay, sir.
okay, so please take out your doubt and we will discuss it. Okay, from Please answer. This is a very simple calculation, everyone. Okay, okay, Sarah. Is it a numerical or a conceptual question?
No, sir, it's clear now.
It's a
It's clear now, sir. I was asking the same question to you.
Tejas, I'm not like you're not clear to me.
Sir,
Please
my
speak
doubts
it
are
again.
clear, sir.
अच्छा, doubts is already clear. चलो ठीक है. Okay. Okay, Sitwa. Sarah Beg, Farhan, and Rumaisa. What about you, Rumaisa? I didn't get your answer. Please be attentive in the class, Rumaisa. I've seen some activities, so please be attentive in the class. Okay. Farhan and Sarah Beg, please answer, बच्चों. Okay, Rumaisa. Okay, Irshad, you are going to change your answer again. ठीक है, चलो. Rumaisa, it's asking momentum. You are giving me the velocity.
Sir, I given you.
ठीक है यार, ठीक है. Okay.
Sir, is it correct?
We'll discuss it. This way, I'll discuss it. Still no answer by Farhan and Sarah Beg. What happened, Farhan? Is it not clear? Farhan? Bache bolo, please let me know. Is it clear or not?
Yes, sir. I'm doing it, sir.
Acha, doing it. Chalo, theek hai. Karo. Chaliye. Giving you one last minute. And those who want to change the answer, you can also change. Farhan, this was the previous question, which is the answer you are giving to me right now. I'm asking the question of answer of this, calculate the momentum of a toy car. It's already done. That the answer you are giving to me, 5 meters per second.
Sir,
Yes, Sarah.
sir, can I change my answer?
हाँ, कर लो, कोई बात नहीं. You can change.
Okay, sir.
Farhan, bache, this question is asking momentum, not the velocity. You are, I think so. You are confused in it. Chalo, I'm
Yes,
solving
sir.
it. Chalo, I'm solving it. That's why I continuously ask to be attentive in the class. That is the reason. Chalo, ठीक है, कोई बात नहीं. Question is saying the momentum of a toy car is 200 grams. So, okay, so 200 gram. So as you see this thing, everyone, that 200 gram is not the SI unit because the velocity given is in meter per second. It means that either we have to change it or we have to change the meter per second into centimeter per second so that we can. But obviously, we are going to do with the SI unit because we do not know any other, you can say, other unit of the momentum. So we are going to stick with the in SI unit. Okay, so 200 grams to convert it into kgs. We have to divide it by 1000 to get converted into kgs. So 2 will cancel this. So this is coming out to be 0.2 kg. Yes or no, everyone? Velocity is given
Yes,
to
sir.
you as
Yes, sir.
Yes,
5 meter per second. Okay, so simple. 0.2, just the value, substitute the values here. Calculate the momentum. M is equals to M into V. Sorry, P equals to M into V. 0.2 into 5 kg meter per second. So there go. 2 5s are 10, but there is a decimal. It means that 0.2 into 5 will be equals to 1 kg, or you can say 1.0 kg meter per second. So Irshad, please work on the conversions, bache. So there is a very silly mistake in your answer. Okay? You
Okay,
didn't
sir.
put the decimal. There was a 0.2,
Okay, sir.
not 2 into 5. Okay? No worries. And Farhan, now you got it.
Yes, sir.
Sarah, your answer was right, but why you were asking to change the answer?
Sir, I thought that 0.2 into 5 would be 0.1.
Generally, okay, कोई बात नहीं. So that is the thing, which you have to work on a little bit the calculations, okay? Because in exams, these mistakes are very common, right? And they are going to cost you for the marks, okay?
Yes.
So everyone, this is all about this class. I'm going just be in the class, everyone. So there will be an assessment of the inertia, okay? So after this class, just even like not more than 5, just check out the assessment after 5 minutes, because I'm right now, I just forgot to mention it. Okay, so just a second.
Yes, sir, no problem.
Okay, so now, okay, after 5 minutes, check the assessment after 5 minutes. Okay, and I will be sharing some question based on the momentum, so you can also practice those questions to basically clarify your concept. Okay, in the next class we are going to discuss the second law of motion along with the and we will do the numericals of the second law of motion as well. Okay, everyone.
Sir, what
So
about
that's all.
rate of change of momentum?
The rate of change of momentum is same. Ifra, we will discuss it. Rate of change of
Can I
momentum is the
leave?
definition of force.
Sir, can I leave?
Okay.
Oh,
Ha, yes.